everyone, welcome to Thermodynamics. In this video, we will talk about Activity 2, specifically tackles about thermal conduction. This is Leo Senelio from BSED Science 3B. Alright, so let's start with item number 1. The R value of a certain building material that is 3.5 mm thick is 2.0. What is the R value if the thickness is increased to 4.5 mm? First, in order to solve the problem, then let's identify the given values. First, given. Alright, so first we have the R1 is equal to 2.0. The R2 or the R value is missing. The L1, alright, so let's have our L1 to 3.5 mm thickness. 3.5 mm. And we have our L2 is equal to 4.5 mm. Okay, after identifying our given, then let's derive our own equation. Okay, so equation here we have R2 over R1 is equal to L2 over L1. Okay, in order to get our R2 value, then let's multiply. So we have here R2 times L1. R2 L1 is equal to R1 and L2. Alright, since we are finding our R2, then we are going to divide both sides by L1 in order to cancel out and R2 remain. Okay, so we have here R2 is equal to R1 L2 divided by L1. Alright, so here, this is now our equation, our formula. So in order to get R2, we have R1 L2 divided by L1. Then let's going to substitute all the given values. Then R1 is equal to 2.0. 2.0. L2. We have our L2 of 4.5 mm. Then divided by our L1 value is equal to 3.5 mm. Alright. So next, we're going to cancel out the same units. We have millimeter and millimeter. So 2.0 times 4.5 divided by 3.5 is equal to 2.54. Therefore, our R value is equal to 2.54. So this is now our R2. So this is the R value if the thickness is increased to 4.5 mm. Next, let's move on to number 1, letter B. What is the R value if the thickness is increased to 1.9 mm? Alright, so first, let's going to identify the given. So the same as here, we have the given of R1 is equal to 2.0 and our R2 is missing and the L1 is equal to 3.5 mm thickness. And our L2 now is our new letter B, the 1.9 mm. Okay. Since we have already our formula, then let's just use this one. equation is R2 is equal to R1, L2 divided by L1. Okay, so let's substitute all the given values. R1 is equal to 2.0, and our L2 now is new 1.9 millimeter divided by L1, that is 3.5 millimeter. Then cancel the same value for the same unit. So 2.0 times 1.9 is equal to 3.8. So we have no value, we have no units. 3.8 divided by 3.5. So our final answer is equal to 1.09 because 3.8 divided by 3.5 is equal to 1.09. So this is now our R2 value. So this 1.09 is the R value if the thickness is increased to 1.9 millimeter. So as we observe here, our R2 is 2.54. The R value of letter A is 2.54 and our R2 for letter B is 1.09. So there is a big difference. Therefore, we can conclude that the thickness is increased to 1.9 millimeter and the thickness here is 4.5 millimeter. As the thickness increases, the R value increases. Okay, so letter B, as the thickness decreases 1.9, as the R2 decreases to 1.09. So this is our answer first. And this is our second answer, letter B. So that's it for number 1. Then let's move on to number 2. Number 2. What is the rate of the heat flow through a glass window that is 2 meter times 3 meter or 2 meter by 3 meter and 1.4 centimeter thick if the outside temperature is 25 degrees Celsius and the inside temperature is 27 degrees Celsius? And we have our given of K is equal to 0.84 joules per second and meter centigrades. Then let's identify our given. Given here, K. Alright, so we have our K is equal to 0.84 joules per second meter centigrade. And change of temperature is equal to 27 degrees Celsius. Alright, so minus 25 degrees Celsius is equal, 27 minus 25 is equal to 2. Therefore, we have our change of temperature of 2 degrees Celsius. And we have our area. Our given area here. Alright, so we have here 2 meter by 3 meter. 2 meter by 3 meter. 2 times 3 is equal to 6 and meter times meter is equal to meter squared. So we have now our area of 6 meters squared. And then the thickness of glass represent as letter L. So thickness of glass, we have 1.4 centimeter. Alright, so we're going to convert centimeter to meter. So 1.4 centimeter. In 1 meter, there is 100 centimeter. Centi means 100. 1.4 times 1 is equal to 1.4 divided by 100 is equal to 0.0 Okay? So let's cancel centimeter and centimeter. So we have that do have meter remain. So this is now our thickness of glass. Represent this letter L. Then let's use our formula or the equation. So change of Q divided by change of temperature of time is equal to K, the area, and the change of temperature divided by the thickness of a material of the glass. Right, so Q is equal, so let's say let's substitute all the given values. So we have here K, let's just copy 0.84 joules per second meter centigrade. The area of 6 meter squared multiplied by the change of temperature, we have 2 degrees Celsius divided by the thickness of a material, that is the thickness of glass, window glass, is equal to 0.014 meter. And then let's cancel out. So we have here divided by 1, imaginary divided by 1. Okay, so we're going to cancel out the same units. We have meter squared, meter here, also the centigrades, and we have J or joules per second remains. Alright, so 0.84 joules per second times 6 times 2 is equal to 10.08 joules per second divided by our length or the thickness of the glass, 0.014. So we have now our answer of 720 joules per second or 720 watts. Right. Therefore, the rate of the heat flow through a glass window is 720 watts in 2 meter by 3 meter and a thick of 1.4 centimeter outside, and with considering the outside temperature of 25 degrees Celsius and the inside temperature of 27 degrees Celsius, and the K value is 0.84 joules per second meter centigrade. So this is now our final answer of number 2. Alright, so on this video, you have learned how to get the R value and the rate of the heat flow. Thank you for watching, everyone.